Hey everyone, welcome back to my channel. Now I'm a YouTuber, I can see. Okay, and right now we will start working with the heat problems. Now today we will start with the first part of the worksheet. I divided into parts because the second part is a little bit more difficult. So let's start with the first one. It says, how much heat is required to raise the temperature of 650 grams of copper from 12 degrees Celsius to 90 degrees Celsius? Okay, if you go at the end of your worksheet, you will find your formula here and all of the specific heats in case I don't put them on the problem directly, okay? And if I forget anyone, you can look for them in the web. So we're searching for heat. Heat, remember, is with a Q. Q equals question mark. And then we have to raise the temperature 650 grams of copper. So we have mass equals 650 grams. We have a specific heat of 0.3845, specific heat 0.3845 joules over grams per degree Celsius. And we have two temperatures, temperature 1 and temperature 2. My initial temperature is of 12 degrees Celsius and my final temperature is of 90 degrees Celsius. My original formula will be heat equals mass times specific heat times delta of temperatures. Let's remember that delta is the difference, is a subtraction. And I need a positive number right here, okay? So from here, I will do my formula again, and it's heat equals mass times specific heat times temperature 2 minus temperature 1. Because in this case, temperature 2 is greater than. If your temperature 1 was greater, you would put temperature 1 minus temperature 2. So heat equals 650 grams times 0.3845 joules over grams per degree Celsius times 90 degrees Celsius minus 12 degrees Celsius. So heat will be, first you multiply these two and you subtract these two. So when you are multiplying them, you will cancel grams with grams. So you multiply 650 times 0.3845 and you have 249.925 joules over degree Celsius. And you multiply it times 78 degrees Celsius. So heat will be equal to 19,494.15 joules, because you will cancel degrees Celsius with degrees Celsius. And this, guys, is your answer. Now you also, with your box procedure, can change it to calories or kilocalories. We're not doing it right now, but it's important for you to know. Okay? I will try problem number 2 now with you. How much heat is required to raise the temperature of 830 grams of water from 24 degrees Celsius to 100 degrees Celsius? So in this case, we have water. We have the specific heat. We're searching for heat. Remember, heat is different than specific heat, okay? Heat is a transfer of the thermal energy. So heat equals question mark. We have a mass of 830 grams, and we have a specific heat of 4.184 joules over grams per degree Celsius, temperature 1 and temperature 2. They're telling you that it's going from 24 degrees Celsius to 100 degrees Celsius. So you have 24 degrees Celsius and 100 degrees Celsius. So we have heat equals mass times specific heat times delta of temperatures. Again, we have mass times specific heat, temperature 2 minus temperature 1. So we have heat equals 830 grams times 4.184 joules over grams per degree Celsius times 100 degrees Celsius minus 24 degrees Celsius. So you will multiply 830 times 4.184, and it's 3,472.72. You cancel grams with grams. So you have joules over degrees Celsius. It's important for you to put in the calculator the 3 or 4 decimal points, okay? Times 76 degrees Celsius. So you multiply it, and your answer is 263,926.72 joules, because you cancel degrees Celsius and degrees Celsius. Please try to do problem number 3 by yourselves. And now I will change to another type of problem. We have 4 different types of problems. This is the second type of problem. In your next class, you will see the other 2 types of problems. These first ones were the ones you were doing in the last video, okay? The example we did with the experiment. Now, in this one, if a piece of platinum with a temperature of 900 degrees Celsius is dropped into 250 grams of water at 27 degrees Celsius, the final temperature of the system is of 42 degrees Celsius. What is the mass of the metal? Okay, important. They're telling you here that you have water, and then you insert the piece of metal into the water, and the metal at the beginning is 900 degrees Celsius, and the water at the beginning is 27 degrees Celsius. What happens? Water will become warmer, and the metal, platinum in this case, will become cooler, okay? And once they are together right here, the whole system will be 42 degrees Celsius, okay? We learned in the past video that the energy or the heat released from the metal is the same that the water receives, okay? So we know that the heat of the water is the same as the heat released by the metal, which in this case is platinum. Now let's put our data here. Okay, so we have water and we have platinum. For both, we need mass, specific heat, temperature 1 and temperature 2. Mass, specific heat, temperature 1 and temperature 2. Let's start analyzing the information. We have 900 degrees, the initial temperature of platinum. So platinum temperature 1 will be 900 degrees Celsius. Then it's dropped into 250 grams of water. So 250 grams of water, we have it here, 250 grams of water at 27 degrees Celsius. So you have 27 degrees Celsius, the initial temperature of the water. 27 degrees Celsius. And the final temperature of the system is 42 degrees Celsius. So temperature 2 of the system, it means that the water will end at the same temperature as the metal. So will be 42 degrees Celsius. What is the mass of the metal? So mass of the metal, and we're missing the specific heat of water, which we already know, and it's 4.184 joules over gram per degree Celsius, and the one of platinum, it's 0.133. 0.133 joules over grams per degree Celsius. Once we have this, we need to pass this information to here and this information to this part right here. We will create an equation like you do them in math. So let's start with the one of the water, which is mass times specific heat times delta of temperature equals mass times specific heat times delta of temperature. You can notice that the only thing I did here is just put heat is equal to what? Heat is equal to this, and heat is equal to this. I'm sorry for the noise behind, it's my daughter playing with her kitchen. Okay, so now we need to identify what shall we do with these two. Let's focus first on the one of the water. The one of the water, you will look at both of them and you'll see that temperature 2 is bigger. So the one of the water will be temperature 2 minus temperature 1. Write it down there. Mass equals specific heat times temperature 2 minus temperature 1 equals mass times specific heat times, focus on the one on the metal, and in the one on the metal, temperature 1 is bigger. So you'll put temperature 1 minus temperature 2. Okay? Now, the next part is really simple. You need to highlight whatever you're looking for. In this case, you're searching for the mass of the metal. So if the mass of the metal is multiplying the rest of the information, you'll pass it what? Dividing to the other side. Okay? Like the rules we have. So don't forget that this one is of water and this one is of platinum. Okay? Again, you're searching for the mass of the metal. So if you're searching for the mass of the metal and it's multiplying the rest of it, it means that according to your equations rules, you'll pass this whole thing to the other side, dividing. Okay? And let's remember again, water and platinum. Now the next part is just to bring your data into your formula. So we have mass of water into the mass of water, specific heat into specific heat, delta of temperatures here, then specific heat here, and delta of temperatures here. Okay? So let's put here. Mass of platinum equals the mass of water, which is 250 grams, times 4.184 joules over grams per degree Celsius, times 42 degrees Celsius minus 27 degrees Celsius. And then divided by specific heat, which is of platinum, which is 0.133 joules over grams per degree Celsius, times 900 degrees Celsius minus 42 degrees Celsius. The first thing I will do is multiply this. I'll put it in colors for you to understand what we're doing. Subtract this. Also subtract this. Mass of platinum equals 250 times 4.184. You have 1046, and you cancel grams with grams, so you have joules over degrees Celsius, and this is right there. Then the next part is 42 minus 27 times 15 degrees Celsius. It's this part right here. And then divided by 0.133 joules over grams per degree Celsius times 900 minus 42, which is 858 degrees Celsius. Okay, and this part is this one. So according to the colors, this is what you are supposed to have. Now your next step is to multiply this part right here and multiply this part right here. So let's do the mass of platinum equals 1046 times 15 equals 15,690, and you multiply, you have degrees Celsius at the top, degrees Celsius at the bottom, so you have joules here, divided by 0.133 times 858 equals 114.114, You will cancel degrees Celsius with degrees Celsius, and you have joules over grams. The next part is just divided. So 15,690 divided by 114.114. I repeat, put all of your decimal points, or at least 3 or 4. If you have 7, you don't need to put the 7 of them. Mass of platinum equals 137.494. You will cancel joules with joules, and your answer is in grams. And this would be the answer of this type of problem. Okay, now I want you to do problem number 5 by yourselves, and I will do number 6 with you. With an initial 250 grams of water temperature at 20 degrees Celsius are mixed with an unknown mass of mercury initially at 500 degrees Celsius. When thermal equilibrium is reached, the system has a temperature of 40 degrees Celsius. Find the mass of the mercury. Okay, so in this case, we have water and mercury, which is Hg. You have mass, specific heat, temperature 1 and temperature 2. Mass, specific heat, temperature 1 and temperature 2. Okay? Again, is when the metal comes into the cup and changes the temperature of the whole system. So, let's start. We have 250 grams of water. So, here, 250 grams of water with an initial temperature of 20 degrees Celsius. So initial temperature here of 20 degrees Celsius is mixed with an unknown mass of mercury. You don't know the mass, so they're probably asking it for. So we have 500 degrees Celsius of mercury, 500 degrees Celsius of mercury. The thermal equilibrium is reached. The system has a temperature of 40 degrees Celsius. So you have 40 degrees Celsius for temperature 2, which will be the same. 40 degrees Celsius and 40 degrees Celsius. The specific heat of water is 4.184 joules over grams per degree Celsius, and the one of the mercury, 0.138. 0.138 joules over grams per degree Celsius. So with this information, let's put our formula. We know that the heat that absorbs the water is the same as the heat released by the mercury. So you put mass times specific heat times delta of temperatures equals mass times specific heat times delta of temperatures. Let's focus first on the one of the water. We can observe that this one is temperature 2 minus temperature 1. So you have mass times specific heat times temperature 2 minus temperature 1 equals mass times specific heat times temperature 1 minus temperature 2. Okay, so in this case, we're searching for this mass. So it means that this other part right here, I am moving it to the other side, dividing. So you have mass of mercury equals 250 grams times 4.184 joules over grams per degree Celsius times 40 degrees Celsius minus 20 degrees Celsius. And let's remember this information is of water, divided by 0.138 joules over grams per degree Celsius times 500 degrees Celsius minus 40 degrees Celsius. So you have mass of mercury equals 250 times 4.184 is 1046 joules over degree Celsius times 20 degrees Celsius divided by 0.138 joules over grams per degree Celsius times 460 degrees Celsius. So the mass will be 1046 times 20, 20,920 joules, because you cancel degrees Celsius with degrees Celsius, divided by 0.138 times 460, 63.48. You cancel degrees Celsius with degrees Celsius and you have joules over grams. So the mass of mercury will be 2920 divided by 63.48. 329.55 to 6 grams, because you cancel joules with joules. And this is your answer. So if you want to earn some extra points for the next exam, please, under this formula, write down from here to here which substance or metal will take more time to increase 1 degree Celsius. Thank you, and if you have any doubts, please look for me. Bye-bye.